Good morning, student. So in this video we are going to start the new lesson, arithmetic progression. Before explaining the arithmetic progression, we are going to understand what is sequence. Our first point is sequence. For example, 1, 2, 3, 4, 5 and so on. What are you going to call it as? It's a set of a natural number, right? Next one, 1, 3, 5, 7, 9, so on. It's a set of odd numbers from the natural number. Next example, 1, 4, 9, 16, 25 and so on. These are the squares of the serial number. You can say square of the natural number, right? 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 15. Here in this you can see it's an odd number. When you are going to add 2 in the previous term, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. Right, here when you are going to add 1 to the previous term, right, 1 plus 1 is 2, 2 plus 1 is 3. So basically you are seeing some patterns, some rules in this. So are the squares of natural number, right, squares of natural number. So what actually sequence is? Sequence is a collection of a number arranged in a definite order to some definite rule, right? So it's a collection of a number. What is sequence? Sequence is a collection of a number with some definite rule. Collection of a numbers arranged in a definite order according to rules. Some rules, okay, some fixed, some definite rule. Clear? So sequence, there you can see multiplication, addition, subtraction, or the squares of a natural number, cube of the natural number, right? So whenever you are seeing some rule in particular collection of a number, then you are going to call it as a sequence, right? Next topic is terms. What is terms in sequence? Second point is terms. Terms in sequence. Okay. Now what is term? For example, For example, 1, 3, 5, 7, 9, so on are your sequence. This is your sequence, right? So terms means this individual numbers are called terms, right? These are terms. So terms in a serial order of a consecutive sequence are denoted by T. So term is represented by T, where you can represent 1 as T1. T1 means first term. This is your T2. T2 means second. T3 means third term. T4, T5 and so on. So basically term is represented by T. And the last term, or you can say nth term, which is represented by Tn, right? And you can say sequence of terms means sequence is represented by Tn in a curly bracket. So this shows that it's a sequence, right? So when you're going to write 1, T1 means 1. You're going to write T2, T2 means 3. T3, T3 means 5 and so on. Clear? So terms means each and every number of the sequence. And terms is represented by terms is represented by T. Now they have given you activity on page number 56. So let's just see this activity. First one, I can say example. See the first example. They have given you the series 1, 4, 7, 10, 13 and so on. When you are going to add in the previous term, means when you are going to add 3, 1 plus 3 is 4. When you are going again plus 3, so you are going 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. So basically you are adding 3 in the previous term. So here you are getting a rule. Addition of 3 means Tn plus 3. Clear? Next. Second example. Second they have given is 6, 12, 18, 24. 6 2s are 12, 6 3s are 18, 6 4s are 24. So basically you can say when you are going to add plus 6 in the previous term, so you are getting next term. Clear? So here you are adding plus 6 in the previous term. Okay. In the third example, it's 3, 3, 3, 3, 3, so on. So basically you are adding 0 in each, right? So when you are adding 0 in the previous term, you are getting next term is 3. Same. Fourth example is 4, 16, 64 and so on. So it's nothing but your what? 4. 4 ones are 4. 4, when you are going to multiply with the 4, 4 4s are 16. 16 4s are 64. So basically you are multiplying by 4 previous term. When you are going to multiply by 4 to the previous term, you are going to get the next term. Okay. Next, the fifth example. It's 1 cube plus 2 cube plus 3 cube. Right? So on. So you can, here it's a cube of a natural number. And the sixth one. Okay, so see the first three example 1, 2 and 3. 1, 2 and 3. You are adding, right? You are getting a next term by adding some numbers to the previous term, right? And here you are multiplying. Here you are doing an addition and here you are doing a multiplication. Clear? And you are just writing the cubes of a natural number. So when you are going to add, when you are going to do the addition with the previous term and you are getting the next term, then you are going to call it as an arithmetic progression, which is represented by AP also. It's a short form. So clear? And whenever you are going to multiply the previous term and you are getting this next term, then you are going to call it as a geometric progression. This is an example of geometric progression, which is represented by GP. GP. Clear? So what is arithmetic progression? Whenever we are going to get the next term by adding a fixed number, you are adding a fixed number. In the first example, you are adding 3 to the previous term. In the next example, you are adding 6. In the next example, you are adding 0. Whenever you are adding a fixed number to the previous term and you are getting the next term, then you are going to call it as an arithmetic progression. And whenever you are going to multiply the previous term and you are getting the next term, then you are going to call it as a geometric progression. This example is, this is not an example of AP and GP, right? Because it's just a cube of a natural number. So you can call it as a sequence, but not a AP or a GP. So this not comes in AP or GP. Clear? So this is just a sequence. Clear? So our lesson name is arithmetic progression. So we are going to study about the arithmetic progression. So as you see in the example, for example, 1, 4, 7, 10, 13. Clear? So the difference between any two, these are the terms and so on. The difference between any two concepts, it's a AP, right? Right? Because we are adding a fixed number plus 3 to the previous term, right? And the difference between each and every consecutive term is same. 4 minus 1, right? Which is equals to 3. 7 minus 4 is 3. 10 minus 7 is 3. Right. So difference between any two consecutive term is fixed. Then you are going to call it as a AP. Right. This is nothing but your what? This is your T1, T2, T3, T4, T5. Right. So this is your T2 minus T1. This is your T3 minus T2. And this is your T4 minus T3, right? And T5 minus T4 is 13 minus 10, which is equals to 3. So you are getting 3 as a common difference. So common difference is represented by D, right? And it should be constant. Then you are going to call a sequence as a AP, arithmetic progression. Then you are going to call it as sequence are in arithmetic progression. Clear? So common difference is represented by D. Terms, you know, terms is represented by T. Common difference is represented by D, and terms is represented by T. Clear? So when we suppose we have to write this in the standard form. So your first term, right? First term means T1 is also represented by A, right? And your next term, now as you can see here, your D value is 3, which is constant, right? So when you are going to add for T2, A plus D means 1 plus 3 is 4. For T3, you have to do A plus 2D, right? 3 2s are 6, 6 plus 1 is 7. You are going to get the T3. And for T4, what you have to do? A plus 3D, right? 3 3s are 9, 9 plus 1 is 10. Clear? So you are going to get the fourth term. So what is this? This is a sequence of arithmetic progression. Clear? Okay. So now we are going to solve example. Again, you can see here 1, 2, 3, 4 and so on. So again you can write it as Tn means nth term will be A plus n minus 1 into D. So this is nothing but your nth term formula for AP. Clear? So now we are going to solve example. See the example. Suppose they have given you the sequence. Clear? 5, 12, 19, 26 and so on. And whether these sequences are in AP or not, right? If it is in AP, then prove it and find the next two terms. So here this is your T1, T2, T3 and T4, right? For AP, the common difference should be same. Common difference means D value, which is T2 minus T1, which is equals to 12 minus 5, 7. Clear? And T3 minus T2, which is equals to 19 minus 12, again it's 7, right? Next, when T4 minus T3, which is equals to 26 minus 19. Again it's 7. So common difference means your D value is 7, which is constant. So therefore the given sequence in AP, right? So you have entered this sequence is in AP, and then we have to find the next two term. For the next two term you have to do the addition of the 7. So for the next two term we are going to do 26 plus 7, which is equals to 33, and for the next 33 plus 7 is 40. So next two term is 33 and 40. Clear? So this is how you are going to prove whether the given sequence is in AP or not, and this is how you are going to find the next terms of the sequence. Clear? I hope you all understood. This is how we are going to